So we're ready to start section 15.6. We actually do skip, it's not an error, we do skip section 15.5. You'll get to do that when you get into intermediate algebra. But basically our learning objective is to use the Pythagorean theorem to solve problems. So this is just a reminder. Suppose you have a right triangle. So that's going to be one side of my triangle. It's going to be my other side. Then I'm going to connect it there. So you have, this is a right triangle, and many times we indicate it's a right triangle by drawing a little square right there. If this is side A and B, these are called the legs, and the side opposite the right angle is called the hypotenuse. Then we have a squared plus b squared is equal to c squared. This theorem has been known for thousands of years in humanity. The history of this is interesting. At any rate, that's what we're going to be using to solve some problems. So let's just solve some. So here we have a right triangle, and this is 1A. And we want to find the remaining side, the length of the remaining side, which is C. So in this case, side 1. So these are called the legs, the A and the B and the C. Let me spell it out as hypotenuse. I'm not for sure if I spelled that right. I should have looked it up. So here I have the two legs, and I want to find the hypotenuse. So that's 6 squared plus 8 squared is equal to x squared. If you want to make the unknown your x, that's fine. So we're just going to solve that. 6 squared is 36, and 8 squared is 64, and that's equal to x squared. So 36 plus 64 is 100 is equal to x squared. So how do we deal with this? Well, let's do it the way we've always done it. I want this to be we're going to derive it. So basically I moved the 100 over to this side. It became negative and a 0 replaced it. But x squared minus 100 is the same thing as x squared minus 10 squared. So that's equal to x minus 10. It's the difference of squares, x plus 10. And we set each one of these equal to 0. And we get x is equal to 10, or x is equal to minus 10. But we're looking for the length. So only one of these matters, and that's x is equal to 10. So here I'm going to give you, we're not going to go through all of that, although we did find the answer here. If we have, I'll write it down here. If C is a positive number which is the square root of b squared, then we have, I misspoke here. Here's my eraser. Let me just give you what to do rather than try, because you all ignore everything I write anyway, don't you? Basically, instead of writing square root, I should have wrote square. Let's solve this another way. We have x squared is equal to 100. And so suppose x squared is equal to 100, and we seek only the positive value of x. And since we're looking for length, all we care about is the positive value, then x is equal to the square root of 100. So what I was trying to say is, suppose x is equal to c, and we seek, you notice how I just said you don't care what I write, and then I erased it, and now I'm writing it the correct way. Suppose x is equal to c, and we seek x squared is equal to c, and we seek the positive value of x. Then x is equal to the square root of c. That's all we're doing right here. So literally, right at this point, right here, rather than going down here so I can get both of the roots, 10 and minus 10, since I'm looking for a distance, distances only make sense if it's positive. I just go, well, if x squared is equal to 100, and all I care about is finding the positive value of x, then x is equal to the square root of 100, which is equal to 10. And we get our answer immediately. And later on, just so you will know, we'll have the exact same property. You'll learn it really quite late. You'll have if x squared is equal to c, then x is equal to plus or minus the square root of c. That'll be introduced toward the very end, because in that case you get both roots, just like we did here doing it the normal way. I got 10 and minus 10. But in this case we only care about the positive one, so when we care about just the positive one, we just take the positive value. Here, this is kind of a mess. I should have actually, we have to figure out, I don't like this, we're not going to do it, because it does not tell you which of the angles is the 90-degree angle. Now, one of them, for us to even begin to use this, one of them has to be the 90-degree angle. And if you look really carefully, it's this one right here. But they should always, always write this in right here, just like they did over here, to indicate which one's the 90-degree angle. So, and the other side is 8. So this is my hypotenuse, and this is my x here. So here I have x squared. It says give an exact answer to 2 decimal places approximation. We're not doing that because you're not supposed to use calculators. And if we were meeting in class, I would ask you to give me an exact answer. So here's leg 1 plus leg 2, so x squared plus the square root of 7 squared is equal to the hypotenuse squared. So that gives me, let me go back to a color we're used to, go down one bit in stroke. So that's x squared is equal to 8 squared minus the square root of 7 squared. So 8 squared is 64, and minus the square root of 7 squared is just minus 7. So 64 minus 7 is 57. So the end result is x squared is equal to 57. So using the property, we want a length, x is equal to the square root of 57. And that answer is exact. Unfortunately, it doesn't really tell us much information because I can't place the square root of 57 exactly on the number line. So to really find it out, you bring up a calculator, and you would find your square root key, hit 57, hit equals to, and it's 7 point, if we want to round off to the 100th place, it's 7.55. So it's approximately equal to 7.55. But notice we can kind of know that the square root of 57 is going to be less than the square root of 64, which is 8, and it's going to be greater than the square root of 49, which is equal to 7. So my answer is going to be some number greater than 7 but less than 8, and right there I have the answer to the 100th place. One last thing. Let's not do these. We're just going to do one more thing, the one that's simple. Because you're not going to get hardly any of these, if any at all, on the exam. But this one's interesting. So suppose a baseball diamond, right? It says doesn't suppose, it says is. So a baseball diamond is a square. So here's first base. No, sorry, I guess that's home. It's been a long time. Here's first base. Here's second base. Here's third base. And this is supposed to be a square. Let's see how bad it is. We're going to pretend it's a square no matter how bad it is. Ooh, it's really bad. So we're going to pretend that this is really a square. And if it were a good square, then each one of these are right triangles. So it says, find the distance from first base to third base. So let's find the distance between first base and third base. So remember, this is supposed to be a right triangle. So all I need to know is the length of these sides. They're saying that's 90 and 90. So this is the hypotenuse C, and these are the two legs. So C squared is equal to the square root, sorry, it's not equal to the square root, I'm not ready to do that yet, is equal to 90 squared plus 90 squared. So C squared is equal to 90 squared plus 90 squared is 2 90 squareds. So now I'm going to take the square root of, I don't like this color, make it a little bit lighter anyway if we're going to stick with that. So now I'm going to take the square root, I'm looking for a length of 2 times 90 squared. That's just equal to the square root of 90 squared. You don't have to do this. You don't have to put 90 squared first, times 2, which is equal to the square root, just using our properties here, of 90 squared times the square root of 2. The square root of 90 squared is 90 times the square root of 2. So the distance here, C, if you want to know how much that is in decimal, is you find the square root of 2 and you multiply it by 90. And that's going to be about 127.3 feet. 127.3 feet. And I have no idea if this is regulation, if these numbers are made up or anything. But there you go. And that's the last lecture of the semester. And I hope you all enjoyed the class, and best of luck on the final.